Hi, hello and welcome. This is the single linked list part 3. In this video I will talk about our goal, reverse the linked list, then I will do the implementation, iterative version, the recursive version of the function, and also I will include another way to do the reverse thing, okay? After that I will add the new operations to the console menu, and then I will show you the code running. So our goal is very simple. We have a linked list, right, like this one, and we want to reverse the elements of the single linked list, okay? If you see, the elements are in the reverse order. The implementation, iterative function. So let me fast forward a little. Okay, we need 3 pointers. The first one is called next, and at the beginning is pointing to null. The second one is the current, that is pointing to head next at the beginning, and the previous will point to current next, okay? And this will run on a while loop. Okay, so the next step is current next is equals to next. So this connection will change to point to the same location as the next. Since next is pointing to null, it will point to null, okay? Then we say that the next is equals to current. So this guy will point to this element. We update the current with the previous, so it will point to this guy. The previous is updated to with the current next, and the current next will be equals to the next, this guy. This connection disappears, okay? What follows is the next is updated to the current value, then the current will be updated to the previous, then the previous is updated with the current next, okay? And the current next is updated to pointing to this guy, and the connection disappears. We need this previous here because if we did not have this previous, we would lose the connection with this structure. Next, the next is updated and the current is updated too, but since current next is null, this while loop will break. Then what follows is we must say that the current next is equals to the next, so this will not point to null, and we must update the head next. We say head next is equals to current. So let's translate this into code. Going here, we say that we need to declare the function void reverse iterative, and it will receive a node t pointer that is our head. And first we need to check if the head next is equals to null or the head next is equals to null. We just return. The first statement says that if the list is empty, we return. The second says that if the list has just one element, we return. You say head next is the first element. If the first element doesn't have a next, it's the only one element on the list, okay? So next we say that we declare the next that is equals to null. We declare a current that is equals to head next, and we put here our while loop, and let's declare here the previous that is equals to the current next. So the first operation is current next is equals to next. We are saying this: current next is equals to next. Next is equals to current. We are updating our next element, and then we say that the current is equals to the previous. We are updating our previous. Then our loop will start again. After the loop is ended, we say current next is equals to next, and head next is equals to current. Just this. Recursive version. First we start with the call where we have three variables, the heads, the n1 and the n2. n1 will point to the head, n2 will point to head next, and head will be the true head, okay, of the linked list. This guy will never change, the head. Next we have another call where n1 is updated, n2 is for this guy, third call 4 and 5. In this case, this one is pointing to null, okay? This is the special case where the loop will break. So, at this point we check if n1 is different from head. If n1 was equals to head, it means that the list was just the head. The list was empty. Okay, so if n1 is different from head, we say that the head will point to the n1. Okay, then we go back. Next, n1 is different from head. Yes, so n2 next is equals to n1. So this connection, instead of pointing to null, will point to this guy. Okay, then we go back. n1 is different from head. Yes, so this connection disappears, this connection is created. n2 next points to n1. Then we go back again, another check, another connection that is broken and another connection that is made, and go back again. n1 is different from head, n1 is equals to head in this case. So instead of pointing to the element, we say that n2 next is equals to null, okay, and the connection disappears. Then we go back and voila, we have our linked list reversed. So let's make this code. Here again in the code we say void reverse recursive node t head, and this is the entering function. This is the function that the end user will call, okay, and this function will just call a reverse rec that receives a head again and head next. So we must declare this function to void this, and it has a node t pointer that is head, node t pointer that is our n1, and node t pointer that is our n2. So you see, the first element is the head, this guy, the second element n1 is this guy at the beginning, and the third is the head next, okay, n2. First we check if n2 is equals to null. We must check if n1 is different from head. If it is different from head, we say that head next is equals to n1. Then we just return, we go away. After this check, this if, we call the reverse rec again, passing the head, the guy that will never change, the n2 that is actually this guy, okay, and n2 next, that is the n2 in the next call, okay. After this returning, we will check n1 is different from head. If it is, we say n2 next is equals to n1. If it is equals to head, we say add n2 next is equals to null. Just this, okay. So the next part is implementing the bonus. Okay, first thing to do is add a function to remove and return the first element, okay. This is very similar to the remove first, okay. I will just copy this and paste. It will return a node t pointer, and I must change the name for let's see, reverse option 3. It will have here a node t to remove is equals to null. Okay, is this guy. What more? We don't need this because we don't want to destroy the element, and we just have to return the to remove. Okay, so the function is the same thing as remove first, but it will return and it will not destroy the node. Okay, so the next step is add a function that receives a node t and add first. So this is similar to add first. We copy this and we paste here. It will be void. Let me put this a comment reverse option 3, and instead of char name and age it will receive a node t other. Okay, so because we have these we can delete this, and other next is equals to head next is equals to other. Okay, so this is the add first. And also I'm almost forgot, we must change the name ro3. Okay, so the next part is reverse function. And the reverse function, we create a new list that is called temp, then we remove from the old and add to the new one. Remove first, add first. Then we repeat the action. Remove first, add first here. So the elements are in the reverse order. Okay, then the last one, the head is pointing to null, is empty, so we must point the head to the new list. Okay, so this is another way to reverse our list. So let's do the code. Going here, we must go, it can be here, and reverse option 3, so you can know where are the things. And we say void reverse and node t receives our head. Okay, then if the head next is equals to null, if the list is empty, or the head next if it has just one element, we just return. We have nothing to do here. Then we declare the temp, and new node is our new list. Okay, then we say while head next is different from null, we must add first ro3 and to temp, and remove first ro3 add, like this. So here we are removing the first element from our list. Okay, and it will return the element, the node, and here we are adding to the temp the returned node from this function. Okay, next we say head next is equals to temp next. Okay, and then we can free the node temp, like this. We are almost done. The next part is the menu. We need to add the option 6 reverse iterative, the option 7 reverse recursive, the option 8 reverse. Okay, so going in the code, we go to the main, and we have here the options. Let me copy these and paste. So we have a 6, 7 and 8, 7 and 8, and reverse, and the first is iterative, the second is recursive, and the third is just reverse. Okay, the next thing to do is the switch case 6 to call the reverse iterative, the switch case 7 to call the reverse recursive, and the switch case 8 to call the reverse. Okay, Let's go to the code. Let me copy this one. This will be the 6, this will be the 7, and this will be the 8. And in the 6 we call the reverse iterative and we pass the list. The second we call the reverse recursive, and the third we call the reverse, just reverse. Also, let me add the print list so we don't have to print again and again. Print, and this one print too. Next thing to do is showing the code running. Let me go here, copy all, going to the REPL, run. The guy is saying that in function reverse recursive, warning, implicit declaration of function reverse rec 235. I know what it is. 235 is this. Here I am calling this function, and this function is declared after. Okay, if I want to do this in this way, I must declare upper at the beginning of the file this, that I have this function, but because I don't want to declare that, I just reverse the order. So I have this function first, the reverse rec, and then I have the reverse recursive. Okay, it's the only thing that I have to change. Copy, let's go here, let's stop this, let's paste, and let's run. Let's increase the size, and let's add last John 13, add last again, Peter 13, add last again, Susan 12. Let's list, let's print, and we have these elements ID 01, 02, 03. Now we can test reverse iterative, the 6th option, and now the list is 3, 2, 1. Reverse recursive, the list is 1, 2, 3, reversed again, and option 8 just reverse 3, 2, 1. It reversed again. Okay, so what's next? In the part 4 we will add more options: add before ID, add after ID, delete an element with some ID, swap elements, and search by ID. Okay, so stay tuned and see you soon. Okay, thank you.